Right, now we're going to look at measuring temperature. So temperature, go ahead and spell that out here. It's a measure of how fast atoms and molecules are moving. So the faster the atoms move, the higher the temperature. And yes, that's like when you touch something, it could be hot, it could be cold, but it's how fast these atoms are moving. So in the metric system, they use Celsius. We use Fahrenheit. Celsius is a little easier to work with in the metric system because the numbers are nice. So water freezes at 0 degrees Celsius. Water boils at 100 degrees Celsius. That makes kind of sense to work with, because if we think Fahrenheit, and I'll fill it out down here, the boiling point for water, you may or may not know, but it's 212 degrees Fahrenheit. The freezing point, I bet you do know, it's 32 degrees Fahrenheit. And those are random numbers. Like 0 and 100 kind of makes sense. 0 degrees, freezing. 100 degrees, hot. Because when we talk about temperatures at outside, 70 degrees is pretty warm. It'd be higher in Celsius, but same difference. So there's also a third temperature called Kelvin. We have what's called an absolute zero there. And there's a number, I think it's 273. I think that's its boiling point in Kelvin. But I don't really use that all as much. If you take a chemistry class or in sciences, that's when you will use it. All right, so here's some formulas that we are going to use to convert between. So we can go from Fahrenheit to Celsius and Celsius to Fahrenheit. We're just going to plug in the numbers and use them. So our recipe calls for the oven to be set at 392 degrees Fahrenheit. What is the temperature in Celsius? So we want to go from Fahrenheit to Celsius. So I'm going to use the formula and I'm just going to rewrite it. So Celsius is 5/9 and then Fahrenheit minus 32. So I'm going to substitute the 392 in for F. So C equals 5/9, 392 minus 32. And then I'll do what's in parentheses first. So 392 minus 32 is 360. I'm going to write it up here. So C equals 5/9 times 360. And I'll times that by 5 and divide by 9 for that 5/9 part. So Celsius, this is 200 degrees Celsius. So let's see if we can do it again for a different one. So 482 degrees Fahrenheit. So the Celsius is 5/9 Fahrenheit minus 32. So I'll do what's in parentheses first. 482 minus 32 is 450. And then I'll multiply that by 5 and divide by 9 to take care of that 5/9. I get 250 degrees Celsius. Or we can go the other way. So a sunny afternoon in May, the temperature in London is 20 degrees Celsius. What's the temperature in degrees Fahrenheit? So we'll use the other formula. Fahrenheit is 9/5 Celsius plus 32. So I'll substitute in the 20. And then we'll do the math. So 9 divided by 5 times 20 is 36. Fahrenheit, 36 plus 32. That gives me 68 degrees Fahrenheit. What is 75 degrees Celsius in Fahrenheit? Well, Fahrenheit is 9/5 the Celsius plus 32. So 9/5 times 75 plus 32 is 167. degrees Fahrenheit. All right, so let's go just a little further with it. Maybe we want to compare values. So a manufacturer requires a vaccine to be stored in a refrigerator at temperatures between 36 Fahrenheit and 46 Fahrenheit. The refrigerator in the local pharmacy cools to 3 degrees Celsius. Can the vaccine be stored safely in the pharmacy refrigerator? Well, let's find out. We could convert both the Fahrenheits into Celsius to get an answer, or we can turn that 3 degrees Celsius into Fahrenheit and see if it fits within that range. So more efficient way would be to convert one number versus converting two. So Fahrenheit is the 9/5 Celsius plus 32. So let's see, 9/5 times 3 is 5.4. And then plus 32 makes 37.4 degrees Fahrenheit. And we just want to know, is that between 36 degrees and 46 degrees? Yeah, it's in the middle, so it works. In July, the temperature in Madrid is 16.7 degrees Celsius. The temperature in Toronto in July is 57.4 degrees Fahrenheit. Which city has the higher temperature and by how many degrees Celsius? So, since it wants the difference in Celsius, let's go ahead and convert this 57.4 into Celsius. So Celsius is 5/9 Fahrenheit minus 32. So 57.4 minus 32. And then if I multiply by 5 and divide by 9, I get 14.1 repeating. So the difference, so 16.7 minus 14.1 is 2.6 degrees Celsius. And which one is higher? Madrid. And when we talk about reasonable values, we can try and do some quick math. So 9/5 as a number, 9/5 is 1.8, and 5/9 is 0.5 repeating. So if we're talking about 1.8 is about 2. 30 is about 32. And then here, if I separated that, that's 1/2 Fahrenheit minus 15. But that's 1/2 is close to that 0.5 repeating. And then 30, again, is close to that 32. All right, so we want to look at some reasonable values, right? So to make candy apples, we must boil the sugar mixture for 20 minutes. What's a more reasonable value to have the temperature when boiling? 48 degrees Celsius or 148 degrees Celsius? So if we want to go from Celsius to Fahrenheit, we could do an about formula. So let's see, 48 times 2 plus 30 is about 126 degrees Fahrenheit. And then 148 times 2 plus 30 is about 326 degrees Fahrenheit. So if we think about the boiling point for Fahrenheit, it's 212, so it's going to have to be the larger one. Or we can go from the perspective of 0 in Celsius is freezing and 100 is boiling. So the only one that's above the boiling point is 148 degrees Celsius. And the average body temperature is generally 98.6 degrees Fahrenheit. So what would a value be reasonable in Celsius? So it's not going to be the same. The values, because there are conversions, formulas, it's not going to be the same. So now we're just going to think, which one would be more reasonable? So let's use the about formula. And we could go from Fahrenheit to Celsius. So using the about formula. So Celsius is about the 98.6 minus 30 divided by 2. So 98.6 minus 30 divided by 2 is about 34.3. So that's going to be the reasonable one. Okay. So now if we just look at, oh, there's more here, hang on. Which represents a reasonable value for a hot summer day. Well, it's all in Celsius here. So we could do the about formulas here. So we know that 100 degrees Celsius is boiling. So that's way crazy for a hot day. That'd be a very, very hot day. So let's do the about for these two. So the Fahrenheit would be about, let's see, 37 times 2 plus 30 is 104. And then the Fahrenheit for the 20 degrees Celsius, let's see, 20 times 2 plus 30 is 70 degrees Fahrenheit. So which one's reasonable for a hot summer day? I would say the 37 degrees Celsius. Some might argue that 70 is hot. But reasonable would be 100 degrees Fahrenheit. All right, now we'll just do some exact ones here. So the temperature in a refrigerator is 4 degrees Celsius. The temperature in a freezer is 21 degrees Celsius lower. What's the temperature of the freezer? So 4 degrees Celsius minus 21 degrees Celsius is going to give me a negative 17 degrees Celsius, which should make sense. In Celsius, the freezing point is 0. So having a negative temperature would mean it's below freezing, and it's a freezer, so it's what we want. All right, at 6 p.m., the temperature was 4 degrees Celsius, but by 6 a.m., it had fallen by 6 degrees Celsius. What was the temperature in the morning? So 4 degrees Celsius, it fell. So subtract 6 degrees, and we get negative 2 degrees Celsius. Again, that's also a freezing temperature value. Our hot dog was cooked in the microwave. The hot dog was 4 degrees Celsius when it was put into the microwave. And then it increased by 59 degrees Celsius when it was taken out. What was the temperature of the cooked hot dog? So it started at 4 degrees Celsius and it increased by 59 degrees Celsius. So 4 plus 59 is 63 degrees Celsius. All right, let's take things a little bit further. The optimum temperature for a chemical compound to develop its unique properties is 392 degrees Fahrenheit. When the heating process begins, the temperature of the compound is 20 degrees Celsius. For safety purposes, the compound can only be heated at 9 degrees Celsius every 15 minutes. So how long until the compound reaches its optimum temperature? So let's turn this Fahrenheit here into Celsius, since everything else is in Celsius. So Celsius is 5/9 times the Fahrenheit minus 32. So let's see, 392 minus 32, and then times 5 and divided by 9 will give me 200 degrees Celsius. So I'm starting at 20 degrees Celsius, and I'm adding 9 degrees every 15 minutes. Now, I don't want to add 9 until I reach 200, right? I want to figure out how far I have to go. So if a total of 200, but I'm already starting at 20. So 200 minus 20, I have 180 degrees left to go. And if I divide these into the 9 degrees Celsius it's going to go, so how many times I need to add 9, it's going to be 20 times. Well, each one of those 20 times is worth 15 minutes. So we'll do 200, or 20 times the 15 minutes. So it's going to take 300 minutes. And that's okay to leave it like that. To me, I can't look at 300 minutes and know what that means. So if I divide that into hours, so if I divide by 60 minutes, because there's 60 minutes in an hour, I get 5 hours. That is a little bit easier for me to work with, only because I don't want to figure out what 300 minutes. I don't want to set a 300-minute timer. I want to be able to say, oh, okay, it's 1 o'clock now. It's going to take 5 hours. Should be done by 6. So 300 minutes is fine to leave as an answer, or you can convert it into a nice usable number or understandable number. So let's see if we can do another one here. So after reaching a temperature of 302 degrees Fahrenheit, a chemical compound cools at a rate of 5 degrees Celsius every 6 minutes. So how long will it take the compound to reach a temperature of 0 degrees Celsius? Well, let's find out what the Fahrenheit is in Celsius. So Celsius is the 5/9 times the Fahrenheit minus 32. So 302 minus 32 times the 5/9 gives me 150 degrees Celsius. Well, I want to deplete that entire thing because we want it to go to 0. And I need to divide it by the 5 degrees Celsius chunks. So that's going to give me that I'm going to subtract 5 30 times. And to find out how long it's going to take, well, that happens every 6 minutes. So multiply that by 6 minutes. So 30 times 6 is 180 minutes. And if you wanted to divide it by 60 minutes to talk about hours, that would be 3 hours. All right. And that is it for temperature. So if you have any questions, let me know.